The Sahara Desert, a place stretching across millions of square kilometers and notorious for its scorching heat, endless stretches of sand, and one of the harshest environments on the planet, has always kept its secrets hidden with unwavering secrecy. But not any longer, because scientists have discovered something under the Sahara Desert that has shocked the entire world.
It was first discovered in 1997 by Egyptian geologist Ali Barakat.
Yeah.
This shocking revelation has the potential to rewrite history and redefine our understanding of this unforgiving landscape. Join us on an extraordinary journey as we unveil what lies beneath the sands of the Sahara Desert. The Sahara Desert is an absolute beast, holding the title of the largest hot desert on Earth. It stretches across a mind-boggling 9.4 million square kilometers, engulfing nearly a third of the African continent. This massive expanse of sand and scorching heat presents formidable challenges for scientists, from extreme conditions to scarce water resources. But these obstacles don't deter passionate researchers. They dare to explore the Sahara's depths, driven by the desire to uncover its hidden wonders and unravel the secrets of our planet's past and the universe itself. With each new discovery, we get one step closer to understanding the mysteries that lie within this awe-inspiring desert. In the year 1996, in the vast expanse of the Sahara Desert in southwestern Egypt, a remarkable discovery occurred that would ignite the curiosity of scientists around the world. Picture this: a tranquil morning, the sun rising over the endless dunes, and Egyptian geologist Ali Barakat embarking on a routine exploration. Little did he know that fate had something extraordinary in store for him. As he meandered through the desert, his gaze fell upon a small, intriguing rock. What could this ordinary-looking stone possibly hold within its depths? Little did he know that these chance encounters would lead him down a path of scientific exploration and cosmic revelation. Now let's pause for a moment and imagine ourselves in Barakat's shoes. You stumble upon a seemingly innocuous rock, but something about it catches your attention. Because of your strong intuition that there might be more to this stone than meets the eye, you decide to keep it. And so Barakat held on to the mysterious rock, embarking on a personal journey to unravel its secrets. But here's the question that arises: what makes this stone so special? What secrets does it hold? As Barakat delved into his study of the stone, he discovered something extraordinary: its extraterrestrial origins. Imagine the amazement and the realization that this stone had come from the vastness of space. But how did he come to this conclusion? Well, Barakat's perseverance led him to travel to laboratories in South Africa, where he could conduct more detailed analyses of the object. It was there that the pieces of the puzzle started falling into place. The stone was later named Hypatia. Hypatia's composition fascinated researchers due to its unusual characteristics and the potential clues it held about celestial phenomena. Researchers Jan Kramers and Georgi Belyanin have been studying the Hypatia stone since 2013, and they have determined that it is of extraterrestrial origin. Analysis of argon isotopes in 2013 revealed that the rock was not formed on Earth. Further research in 2015, examining noble gases in the fragment, suggested that it does not correspond to any known type of meteorite or comet. Now let's take a moment to ponder the implications of this discovery. We have in our hands a stone that defies the boundaries of our planet. But where did it come from? What cosmic event could have given birth to this enigmatic stone? The answer lies in the composition of the Hypatia stone, which is a fascinating aspect that sets it apart from other natural objects, both terrestrial and extraterrestrial. Now you must be wondering how scientists unravel the mysteries of enigmatic stones from outer space. Well, when scientists examine meteorites, they look for specific clues within their composition to understand their formation and extraterrestrial origins. In the case of the Hypatia stone, researchers have conducted extensive analyses to unlock its secrets and shed light on its remarkable nature. One striking feature that sets the Hypatia stone apart is its composition, which differs from other rare meteorites, including primitive and metallic ones formed during the early stages of the solar system. Primitive meteorites offer valuable insights into the early solar system, as they have remained relatively unchanged since their formation billions of years ago. These meteorites contain chondrules, tiny spherical grains that formed from molten droplets within the solar nebula. However, unlike primitive meteorites, the Hypatia stone does not exhibit the typical chondritic structure, suggesting a different origin and formation process. On the other hand, metallic meteorites, predominantly composed of iron-nickel alloys, originate from the cores of differentiated asteroids. These dense and metallic meteorites are relatively rare compared to other types. However, the Hypatia stone does not share the high iron content and metallic properties characteristic of metallic meteorites, further emphasizing its uniqueness. If the Hypatia stone is not made of the same stuff as primitive or metallic meteorites, what makes it so special? To delve deeper into this mystery, scientists have conducted meticulous analyses of its elemental makeup. Researchers have found that the Hypatia stone consists of two distinct matrices, or structures, within its composition. The first matrix is bimodal and carbonaceous, while the second matrix exhibits a more complex compositional pattern. These matrices hold vital clues to understanding the origins and formation of the stone. Let's delve into these terms and unravel their significance in understanding the nature of this cosmic enigma. The first matrix of the Hypatia stone is described as bimodal. To grasp the meaning of this term, envision a spectrum with two distinct modes or patterns. In the context of the Hypatia stone, the bimodal nature refers to the presence of two distinct compositions within its structure. It's as if two cosmic brushstrokes converged, resulting in a mesmerizing contrast within the stone. This bimodal characteristic sets the Hypatia stone apart, making it an exceptional and intriguing specimen for scientific study. Moving to the second matrix, we encounter the term carbonaceous. Carbonaceous simply means that the matrix contains a significant amount of carbon. Carbon, a fundamental element of life on Earth, plays a pivotal role in shaping the properties and characteristics of the Hypatia stone. It infuses the stone with its unique qualities and adds to its enigmatic allure. The carbonaceous nature of the second matrix sets it apart from other meteorites and celestial materials. While some meteorites may contain traces of carbon, the Hypatia stone embraces carbon as a defining feature. The presence of carbon in such abundance within the matrix suggests intriguing possibilities about its origin and the processes that shaped it. It serves as a reminder that even in the depths of space, the building blocks of life can find their place in the cosmic tapestry. In addition to its carbonaceous composition, the second matrix of the Hypatia stone exhibits a complex compositional pattern. This complexity suggests a rich interplay of various elements and compounds. The combination of a bimodal first matrix and a carbonaceous complex second matrix showcases the intricate and extraordinary nature of the Hypatia stone. These terms provide valuable insights into its composition, prompting further investigations and posing intriguing questions about the cosmic events that gave birth to this celestial wanderer. It is within this second matrix that crucial clues about the stone's origin lie hidden. Using ultra-sensitive X-ray emission analysis, scientists have detected a remarkable array of 15 different chemical elements within the second matrix of the Hypatia stone. What's truly astonishing is that the pattern of elemental concentration in this matrix is unlike anything ever observed before. The scarcity of silicon and manganese, combined with the abundance of iron, distinguishes the Hypatia stone from other carbonaceous chondrites. These unique chemical signatures raise intriguing questions about the stone's formation. How did it acquire such a distinct elemental composition? What cataclysmic extraterrestrial events shaped its remarkable characteristics? One prevailing hypothesis suggests that the Hypatia stone originated from a Type 1 supernova, an explosive event that occurs in binary stellar systems. During a Type 1 supernova, a white dwarf star reaches a critical mass, triggering a cataclysmic explosion and dispersing its matter and byproducts across interstellar space. The Hypatia stone's composition, particularly its iron-rich components, aligns with the expected derivatives of such a supernova. Yet, as we wander through the cosmic tapestry, we encounter unanswered questions, like untrodden paths yet to be explored. The mysterious elements within the second matrix defy our current understanding of Type 1, a supernova. What hidden forces shaped this stone? What cosmic alchemy weaves its intricate threads together, forming the enigma we now seek to unravel? The Hypatia stone is a cosmic muse that invites us to contemplate the grand tapestry of existence. Its composition, a symphony of elements, resonates with the echoes of distant stars. With each discovery, we inch closer to understanding the cosmic forces that birthed this celestial wanderer and cast it upon the desert sands of Egypt. The elemental composition of the Hypatia stone provides crucial evidence that supports the hypothesis of its extraterrestrial origin. Its distinct chemical pattern, combined with the presence of micro-diamonds, suggests that it likely formed through an extraordinary cosmic event. However, it is important to note that the Hypatia stone's composition presents certain anomalies. Not all elements detected within the stone's second matrix correspond to the expected chemical signatures of a Type 1, a supernova. This discrepancy raises further questions and suggests the existence of additional factors and unknown conditions that influenced the stone's formation. The composition of the Hypatia stone is truly awe-inspiring, isn't it? What other secrets do you think the Hypatia stone holds? Share your thoughts in the comments section, and make sure to subscribe so you won't miss any future explorations.